Morning, everyone. Hello, welcome. I'll just give it a few more minutes to let people join and settle in, and then we'll get started around, well, probably maybe give it 4 or 5 minutes, about 5 past. And people are starting to join now, so I'll leave it a couple more minutes. Okay, we've got a reasonable amount of people now, so let's get started. Welcome, everyone, to our live session. Thank you very much indeed for taking the time to join us to learn about real-time intelligence in Microsoft Fabric. Before we jump into the session, let me introduce you to our speakers for today. I'm David. I will be facilitating the session. I'm presenting. We have Sam, our principal consultant based in our UK office in Reading, and Lohit, who is one of our senior consultants based in our office in Hyderabad. We all work for Coeo, an accredited Databricks partner and a tier 1 Microsoft data and AI partner with approved Microsoft specializations in analytics, infra and database migration, AI and machine learning. Coeo provides consulting services including end-to-end data strategy, SQL migrations, data governance, data engineering, visualization and AI, along with operational support via our managed services team. We've got a lot of interesting content to cover today, and we'll have time for some questions at the end. We'll be monitoring the Q&A window as we go through, so please feel free to drop any thoughts, questions or points for discussion into that Q&A feature, which I'll highlight now. I'm just going to post something in there. Hopefully that's come through. Somebody give me a thumbs up. Okay, thank you. Right, I think we're all set. So with that, I'll now hand over to Sam and we can get started.
Thanks, David. Today, we're going to be talking about how we turn everyday data into immediate action. So not faster dashboards, not prettier reports, but shrinking the gap between something happening and something being done about it. Most organizations don't have a problem collecting data. They have an issue acting on what that data tells them in the appropriate timeframes. By the time we see issues, pipeline failures, API spikes, order problems, the action window to prevent those issues becoming a problem has already started closing. Today, we will look at how we can act on that data immediately. But first, I want to reset our thinking about what real-time is. When people hear the term real-time, they usually picture something quite extreme. Streaming platforms, massive IoT feeds, millions of events per second, highly specialized data architectures, and that immediately makes real-time feel complex, expensive, and often even unnecessary. So there's three myths that consistently get in the way of real-time adoption that I want to discuss. Firstly, myth one, real-time equals streaming only. It's not true. Your organization already emits lots of continuous signals. Every pipeline run, every API call, every order status change, each of these are an event. And these events are happening continuously, whether we label them as real time or not. Myth number two, we need huge data volumes to justify real time. Actually, the opposite is often true. Some of the most valuable signals are more often than not the infrequent low volume signals. A failed payment, a delayed file, a broken pipeline, servers infrequently spiking resources. Those events aren't high volume, but they are of high consequence. And myth number three, real time is just faster ETL. Well, no, it's not. Real time is not about refreshing dashboards faster. It's about closing the loop between something happening and something being done about it. That loop of observe, decide, and act is what changes outcomes. And today, the real-time loop is what we're going to be unpacking. So, if real-time is not about maximizing speed, what is it about? And real-time is about minimizing our time to action. And that's the mindset shift that I would like to focus on today. Let's give a real example that we quite often see. If we imagine a revenue dashboard containing all of the key KPIs that we need as a business, the dashboard has recently been updated, so it now refreshes every hour instead of every day. It sounds impressive, but if there was an issue detected on the dashboard at 9:01 this morning, and no one takes any action until tomorrow morning, what did the faster refresh speeds actually help? What action did it enable? Speed without a response is just noise. And shrinking that gap between detecting an issue and acting upon it is the win that we can have here. Because the longer that gap is, the more expensive the delay becomes. And that might be expensive in terms of costs, missed SLAs, or expensive in terms of time spent people working on these issues. And as I said, most organizations, we don't have a data problem. We have a time to action problem. But why does time to action matter? And you already have real-time signals across your environment. In data teams, pipelines fail, files arrive late, jobs run longer than expected. In applications, API errors spike, we have latency issues, increased number of authentication failures, etc. Business teams care about order business processes such as order status changes, payments failing, and maybe inventory dropping below a threshold. None of these things are rare events. They're happening constantly. But the issue is we tend to treat them as batch events. We'll check these things via dashboards that we look at tomorrow. We review logs later. We find out there's a problem after somebody has complained. And that has all of those things create a delay, and that delay creates scenarios where small issues become major incidents. So maybe a missed file becomes a missed report. That missed report becomes a revenue conversation, and the revenue conversation becomes an executive escalation. And that escalation didn't occur because we didn't have the signal, we didn't have the data. The escalation occurred because the time for action window had closed before any action was taken. And that is what we mean about having a time to action problem. We're not acting within that window. So what can we do to actually reduce our time to action? And it's not just about using tooling. It's not just about streaming. It's not just about alerting. Real time it's a loop, and the loop is, as shown on the slide, we have signal, detect, visualize, and act. So signal is we're capturing events from across the business, as I mentioned, pipeline failures, API issues, order status changes. Then we have to detect any patterns or anomalies that represent the issues that we want to be acting on. Then once we've detected these issues, we need to visualize them. Everyone needs to be able to see one consistent version of these issues in real time. And then finally, once we can see the issues, we need to act on them, whether that be raising tickets, sending emails, initiating corrective workloads. And if any part of this chain breaks or is missing, we are going to increase our time to action. So if we detect issues but we don't visualize them, people across the organization won't be aligned. If we visualize issues but don't automate, we're going to have slow response times. And if we were to signal but not detect, we'd have blind spots, we'd be missing issues. It's only when this whole loop is working together as one that we can close that time to action window. So, in closing that loop is where Fabric Real-Time Intelligence fits. Fabric gives us the tools that map directly onto this real-time intelligence loop. As you can see here, it's the same loop with the Fabric components added. So loop starts with signals entering our systems, and we have event streams to gather the signals. To detect patterns, we have KQL and KQL databases. To visualize the results, we can create real-time dashboards, and then to act on these issues, we have Activator. And it's when we combine these components, we create the visibility and automation you need to reduce your time to action. So let's think about how many. So when an issue occurs, let's think about how many steps usually happen. So number one, something breaks. Then number two, somebody will notice. 3, they send an email. 4, somebody else investigates. 5, we open a ticket. 6, the ticket gets escalated. And 7, someone finally takes some action. So we have potentially 5 steps between something breaking and some action being taken. Each of those steps at best takes a few minutes. At worst, I'm sure we've all seen it take days, even weeks, for tickets to be escalated. And that all creates this latency. And real-time intelligence in Fabric removes the need for those middle steps. It removes that latency and between something breaking and action being taken, and reduces our time to action. So now we'll just have a walk through the real-time intelligence components that I've mentioned in the loop. So firstly, we have event streams, and these are where signals enter the system. And event streams are about ingestion and routing our events. But more importantly than that, they're also about normalization. Often we see situations where logs are here, pipeline metrics are there, application logs live somewhere else, and not only are the different logs in different locations, they all look slightly different. Event streams standardizes those logs. Everything becomes an event, and once everything is an event, everything becomes more observable, more actionable, and more importantly, can be observed and actioned as one. Without the standardized signals, our detection is going to be fragmented, and that fragmentation will increase our time to action. So once signals are flowing in, you need fast detection. And this is where KQL and KQL databases come in. It's not just about storage, it's about recognizing patterns. With KQL, we can ask questions like, has this failure happened more than 3 times in the last 5 minutes? Did my latency spike beyond the threshold? Has a critical pipeline missed an SLA? And more importantly than asking those questions, we can answer them instantly. So why does being able to answer them instantly matter? It's because most monitoring systems today rely on some form of polling or batch checks or periodic evaluation, and those techniques they create delays. KQL allows us to have event native detection, and seconds may matter here because the difference between detecting an issue in 30 seconds and detecting it after 30 minutes could completely change the impact of any action we are able to take to resolve that issue. So once issues are detected, they need visibility, and real-time dashboards in Fabric provide that live operational view of signals and the detected issues. So by having that one live operational view, we have no issues such as refresh anxiety, wondering when information was last refreshed. There's no stale screenshots. There's no debating the accuracy of data based on its timestamps. Everyone is looking at that same truth at the same time, and that alignment reduces any confusion, because we often see many incidents. They don't become escalated due to a lack of information or data. They become escalated because people are misaligned and have different views of that information and data. So having that live visibility creates a shared context and understanding that lets us act as one. And talking of acting, the last step where the loop closes is Activator. So Activator is Fabric's rule engine that allows you to react to various conditions. And this is where most organizations fall short. We're able to detect, we're able to visualize, but we're not automating. And no automation means a human still needs to notice and act. Activator allows us to define rules such as if a failure count exceeds a particular threshold. So if CPU exceeds 90% for 5 minutes on a server, we might want to do something such as send a Teams notification, create a ticket in a help desk system, or trigger other custom workflows that might be far more correct, go as far as correcting the problem automatically. But whatever the action, the system is now reacting instantly, and that has a multiplier effect, because this automation doesn't just reduce our response time, it reduces the workload upon your teams of engineers. Your teams don't have to be constantly watching dashboards, looking for issues. The system is watching for them, and that creates this difference between having reactive monitoring and responsive systems. So let's just zoom back out to our real-time loop again, where we have our signal, detect, visualize, and act. And so that's the real-time loop. And once you build a real-time process once, you can you can replicate it. So we'll have different signals, but it's always the same pattern. Whether it's a pipeline failure, a payment issue, it's the same loop. We detect, visualize, and act. And also like to emphasize that real-time intelligence isn't just for data engineers or analysts. Everyone in your organization is a potential real-time intelligence user. Data teams care about pipeline health, app teams care about performance, business teams care about outcomes. The loop applies everywhere. The only difference is the signal being fed into it. Once we internalize this pattern, we'll start seeing opportunities for real-time intelligence everywhere across the organization. So Lohit's now going to demonstrate what I've been talking about and how these and how real-time intelligence in Fabric can be put into action.
Thank you, Sam. So before the demo, so I would like to talk about few examples of it. Organizations generate huge volumes of data from multiple sources such as IoT devices, websites, financial transactions, applications, and sensors. The true advantage lies not merely in accumulating this data, but the ability to analyze and act on it immediately. So when organizations respond immediately, they improve efficiency, reduce losses, and enhance customer experience. The examples we can use in the real-time intelligence, detecting fraudulent financial transactions, monitoring production equipment to prevent breakdowns. And the current demo which we are looking at is an prevent server impact in real time. Moving on to the next slide. So imagine you are in an organization and you have an IT team and you are part of that IT team and you have a lot of servers. Your IT team wants to know immediately when the server is running for a longer time and it's overloaded based on the few metrics like CPU usage, memory usage, so that you can act on it immediately even before the users are getting impacted. Okay, if you clearly see, right, the signal is for us is a CPU and memory. The detection is the certain overload, and the act is triggering alerts to it, to the users. Okay, so moving on to the next slide, where we talk about the demo data set, where we capture multiple columns. Okay, you want to see multiple columns here on the identity columns, such as event ID, which is going to talk about events, particular events, IDs, device ID and session ID. Okay, and the time based columns, which are like session start timestamp and session current time, and the health metrics, CPU usage, memory usage, and the current users. And the additional information which we added to this demo data set was the contact person. Okay, whom to contact, whom do we alert the contact. Okay, this is a simulation we created it. The data set is a simulation which we have created it for the demo purposes. Okay, and in order to start for you to test also, you can use sample data sets and the real-time intelligence in Microsoft Fabric, which we're gonna see in few minutes. Moving on to the next slide. How did we create this demo data set? Okay, we used Python. Okay, and we attached this Python data. Apologies. Okay, we use this Python script to generate events and attach this data as a source using the custom endpoint using SAS authentication, key authentication in the event streams, which will generate the events in the form of JSON. Okay, and you want to see them in next slide. Okay, for the in the interest of time, we have recorded the entire demo, which is in the next slide. And once the demo is done, we're going to talk about it. Thank you, sir. These are the sample events. Okay, you're going to see all the columns here one by one. Okay, they are generated randomly. Okay, using a script. And we're going to utilize these events one by one, and we're going to send it to the event streams. and we're gonna create them as our source. Let's move to the Fabric workspace. Once you log on to the app.fabric.microsoft.com through your ID, on the left side you will see workspaces. You can click on my workspace or any workspace dedicated to you, and you can start creating on an item. If you click on the item, you'll want to see all the items. The one which we are more interested is an event stream, and create a new event stream for us. And once you create the event stream will look like this. If you clearly see, right, you can add the source. You can connect multiple data sources here. The recommended one is an Azure Event Hubs, and there are multiple sources which you can attach. Okay, and there is sample data you can test on it, and there is custom endpoint. Since we are using a custom endpoint, we have already created an event stream, and we're gonna directly go there. So once I start attaching the source, now you'll be seeing an edit mode here, which you can edit. Again, you can add the destination, or you can transform events, which we're gonna see later. Let's add one destination as an event house for us. Okay, and just connect it. So I'm gonna use the event processing before ingestion method, and I'm gonna uh, keep this then the destination name as event house as it is, and I already have an event house connected. I'll just give the name, or else you can create a new one, and you can create a new table. I already have a table. I'm gonna just activate it and then save it and publish it. Let's get the event house. Once it gets activated, let's see. Once the event house is active, let's get into the event house to see how the data is flowing. In the Fabric demos, we just had an event stream. You can directly click on it and you can see the server details server here and the particular table. Once it gets created, you're gonna see them. You are seeing right now 168 rows came in, and the preview of the data is here. And let's see real-time dashboard. Let's click on the real-time dashboard, which I have already created it. This is the real-time dashboard. If you clearly see, right, that the total number of events, the total users, maximum CPU usage and maximum memory usage, and high data usage details here, and the CPU usage chart for the top 4 and how the data flows. Okay, you can, this is in viewing mode. You can go to edit mode and you can add much more details to it. Now I'm adding a refresh rate to this right now, and it's gonna refresh on per every 10 seconds. And you can go and add it as an auto refresh also. Everything can be applied here by default. So you see the data is moving right now. Okay. If you are wanted to do still some more detail dashboard, in this dashboard, if you wanted to add additional tiles to this, you can simply run the KQL on whatever wherever you are seeing the, you can simply click on the KQL and you can just run it through and add a visual to this once the results have been there, and click on apply changes, and you want to see if you add a visual, it is coming as an table format. You can change the respective format which you can need. Okay, here at the visual, and you can close and you can apply the changes. You'll be able to see directly here all the details right now. This is about the real-time dashboard. Let's see the activator in the event streaming. Once we are on the event stream, okay, we're gonna click on the edit, and we're gonna add some transformations to this, add one small filter to this before we add an activator to this. And the filter is CPU usage. greater than 90. And I'm gonna add the CPU usage filter where the value is greater than and the value is 90 here. And let's save it. And let's add our final destination as an activator. Once I have added the activator, it's gonna come like this. You're gonna give the name to the activator and the workspace, whichever the workspace you are attaching to, and the activator. You can create a new activator. As I already have an activator, in the interest of time, I'm just attaching it, and the data sources and the input data format. I have the JSON input data format, just I'm keeping it as it is, and then I'm gonna publish this. Once the publish is completed, your activator will be active. Now you can see the activator is active. Let's go to the activator to see how the activator looks like. So if you clearly see, right, there are events coming up inside the activator, and there you can create a new object to see how the data looks like. Okay, you can create a new object and you can select a unique identifier to this object and see based upon how the data is. And you can also add a new rule to it. Okay, where you can give an additional condition to the new rule and see how the data is. As I already created one rule. So it's going to send an email to the person, to the contact person, stating with a subject and with a headline where I have added all the required columns in the context along with that, and I'm gonna save and start this action. And we're gonna see how the email and the Teams message gonna look like. And coming to the actions, you can also, apart from Teams, you can also send multiple actions like run pipeline. You can run a Spark job, run a notebook, run a function, and you can create a custom action also. In the Teams, it also supports message to individuals, group chat message, and the channel post also. Let's see how the email and the Teams message look like. These are the samples. Moving on to the next slide. If you once you start on the trigger emails, okay, once you start on the triggers in the activator, you're gonna see the emails based on the conditions you have set. Okay, in this format, the data comes from my Fabric activator, and it has an headline to it and the context to it, whichever the columns we have it. It's gonna share the details whatever we have attached to it. And moving on to the next slide, we have also added Teams. Okay, in this Teams, you're gonna see the similar data over here. Okay, where there is an headline and the subject and the context columns. Okay, while sending the Teams in between Teams and emails. Okay, in order to act too fast, you can trigger a Teams messages. And if there is some situation where there is no data, you wanted to act upon it after some time, you can choose an emails. You can also add additional workflows, Fabric workflows to it. Okay, you can run a notebook as multiple actions have been there. You can attach multiple actions to this at an activator. Thank you. Moving on.
Thanks, Lohit. So now Lohit's shown us some of the real-time intelligence tools in action. I wanted to move on to talk about how you can begin to implement real-time intelligence in your organization. So just taking a step back for a moment, what we just saw was not a completely new separate platform. It was not a new architecture. It was not a 6-month migration program. All of that was already inside Microsoft Fabric. And that's important because one of the biggest blockers to real-time adoption is the perceived complexity. So, teams will assume that real-time requires new technology stacks, dedicated engineers, complex operational pipelines and DevOps processes. But what was just demonstrated was the entire real-time loop already existing in Fabric. So we had signal ingestion, we had pattern detection, live visibility, automated responses, and end to end, and that was already in Fabric. So if you're already using Fabric, you already own these components. So this isn't about buying new capability, it's about activating capabilities you already have. And that changes the conversations from can we afford this to where should we apply this first. And it's a very different starting point. So, mistake many organizations make when trying to implement real-time intelligence is trying to boil the ocean. They'll say, let's make everything real-time. And although the excitement's good, it's not how it best works. It's real-time maturity works best when you start small. So following a pattern of one signal, one view, one action. Take that and build that as your small starting point. But so to make that a bit more tangible, one signal might be we're looking for a signal where we can't wait until tomorrow to know about this. We want to detect and find it now. So that might be a failed pipeline. A payment status changes to failed. API latencies are exceeding SLAs, whatever it might be. Find that one signal where we can't wait till tomorrow. We need to know now. Once we've found it, create one view of that signal. So it might just be a dashboard with a single tile that shows a failure counter, or it might be a trend chart, or anything similar. Just one simple visual is all you need to visualize that one signal, and then just take one action. So that might just be a Teams notification. It might just be an email. It might be triggering a workflow that will correct the issue if we already have it, but it doesn't need to start that complex. And once we've got that signal, view, and action, that's our first win. We've got a real-time signal going through the real-time loop, and we've got an action coming out of the end of it. And so slide here showing how you might want to go about approaching that within 7 days, within a week. We could define we could define the win, define the what we want to know about. We could use event streams to stream that signal. We can start using KQL to detect it, use our dashboards to make it visible, and Activator to start automating a response. Then we might need a couple of days of where we want to tune. We want to apply a bit of tuning. So we don't want to have. We might find initially we've got our activator conditions not quite right, and we're getting too many alerts. So a little bit of tuning, and then operationalize it, put it in production, and agree what the next steps are. So within 7 days, could have that first real-time win. And what that first win will do is something hopefully quite powerful. It will start changing behaviors, because once other members of teams start seeing processes that used to take hours taking minutes, it will start to build momentum. And as you start to build that momentum, one of the key things say is you don't need perfection. What you need is impact. So where I said start simple, and it might be that a Teams notification it creates that impact of it makes somebody look at this issue straight away. That might be a relatively small impact, but we can iterate over time. And if we start using those more using Activator to fire off notebooks and other larger, more complex workflows, we might be able to correct the problem without a human interaction tool, and that then becomes a much bigger impact. But don't let that perfect end goal prevent you starting with that small impact. Get that small impact today. As I said, key thing is pick something where tomorrow is too late and start there, and that's how your real-time adoption will begin to spread. So the the three things I really want you to walk away from this session today with are, firstly, real time equals time to action. It's not about speed. Speed alone doesn't create any value. It's the response that creates the value. If we have dashboards that are updating fast, but our response to that data is slow, nothing's going to change. Secondly, real time is our signal to action loop end to end. We need to signal with event streams, detect with KQL, visualize with dashboards, and act with Activator. It's not one or some of those components, it's a loop that contains them all. And if we break the loop anywhere, that time to action will begin to expand. And lastly, automation is the key multiplier. Without automation, we're relying on humans to constantly monitor and act. With automation, the systems are doing the monitoring for us. And that's where the scalability comes from, because it's much easier for us to scale systems than it is for us to scale people. So thank you very much for listening to us today, and hopefully we have some questions.
Yeah, there's nothing in the chat window at the moment, so please do post any questions you have. Oh, hold on, sorry, Roland, we've got a question there. Sorry, let me just look at that. It's in the chat. So the question there is, what capacity do you need for this? Is F2 too small?
Okay, so you can run real-time intelligence on an F2, but like with anything, F2 is probably going to be too small to run any significant production-sized workloads. But yes, you can start from an F2 and scale up depending on the size of what you're trying to achieve.
Okay. Any more questions? Do post them, as I said, in the Q&A thing. While people are thinking about that question I've got, how should we measure success? Are there particular KPIs that prove that this is more than just sort of faster reporting?
So, if we want to measure success in terms of KPIs, we could be looking at things such as the time it's taken to detect an issue, time it takes to respond to an issue, if we're already measuring those, so we've got something to compare them against. But we can also look at things such as the number of incidents and their severity, because if we're catching issues earlier, they're going to be smaller, they're going to be less severe. So we might start seeing a drop off in P1s because we're catching things when they're only priority 3 or 4, or but you could also measure it in terms of potentially operational costs, because with the automation and potential resolution of issues is going to free up engineers to be working on the newer, more exciting sort of new feature workloads rather than sort of business as usual bug fixing, issue resolution. So you might see a more productive teams as a result. It's another way of measuring it.
Okay, no, that's really useful. Thanks, Sam. Any more questions? Check. I'm just sort of flicking between the chat window and the Q&A stuff. Well, I've got another one for you then. How do you prevent alert fatigue?
Right. So I touched on it slightly, but when we set up our Activator alerts, we don't want to be creating alert fatigue. So if every day you come in, you have an email in your inbox, the overnight data warehouse load completed successfully, we're going to create rules, start hiding the email alerts, and probably end up missing the important one eventually. So making sure that we're creating alerts only when they're important and when and often when things have gone wrong for a sustained period of time. So using Lohit's example of CPU exceeding 90%, it might be okay if CPU exceeds 90% in a 2-second spike, but if it's been over a 90% for more than a minute, maybe that's something we want to look at. So the activator lets us set up rules where not only has something gone wrong, it's sustained that its position above that threshold for a particular period of time. And we can also set up different tiers of alerts. So you could have warnings and errors, where critical errors, we get Teams notifications, emails, all sorts of things, different alerts being fired off. But maybe warnings can be dealt with in later, because we have a much larger time to action window for warnings. So maybe they only get a Teams notification and the one alert. So you can use that severity to reduce the number of alerts someone gets. But the particularly important thing to remember about that is when we need someone to take an action, we want the right number of alerts to provoke that action, and prevent whatever the issue is from having a negative impact.
Okay. No, that's really helpful, Sam. Thank you. It looks like there are no more questions. So I think all that's left is to thank you all for attending. We'll share the slides and a recording along with some helpful links by tomorrow. If there are any questions that spring to mind after the session about the content we covered today, or more generally about how Coeo can support you and your organization on your data and analytics journey, please feel free to reply to the follow-up email that we'll send. It's a monitored inbox, and we'll be around to reply to any of those questions. In March, we'll be covering Databricks fundamentals, so keep an eye out for the registration link. Thank you, Sam and Lohit, and thank you everyone for joining. And we hope we see you all on our next live session next month. Thanks, everyone. Really appreciate it.